All right, today we're going to pull back the curtain on a technology that's quietly reshaping our world, one prediction at a time: machine learning. This isn't science fiction anymore. It's the engine humming in the background of your everyday life. So what is it really? Let's dive in.
So what we're doing here is basically cracking open a university-level textbook on the topic and translating all those powerful academic ideas into something that's, actually fun and easy to understand.
So think about this. You just finished an awesome movie, and bam, another great recommendation pops up. How in the world does it know? Is that just a lucky guess, or is there something else going on? Well, that crazy accurate prediction, that's machine learning. And it's not just on Netflix. It's the same tech to keep spam out of your email, flags weird charges on your bank account to prevent fraud, and even helps self-driving cars see the world around them, telling the difference between a person and a fire hydrant. It's literally the invisible engine running our digital lives.
Okay, so it feels like magic, right? But what's actually happening behind the curtain? Let's dive into how it really works.
So here's the big idea. At its heart, machine learning is all about teaching computers to learn the way we do, from experience. Instead of a programmer sitting down and writing millions of lines of code with super rigid if this then that rules for every single possibility, we just let the machine figure out the rules for itself. And it does that by looking at a ton of data.
And this right here, this is the core loop. It's super simple when you break it down. The machine gets data, it finds the hidden patterns in that data, and then it uses those patterns to make predictions about brand new stuff it's never seen before. Learn, identify, predict. It's this constant cycle of getting smarter.
And that idea, that whole concept of learning the rules instead of just being told the rules, well, that is the fundamental shift. That's what gives machine learning all of its incredible power.
Check this out, because this slide really shows how ML flips the old way of programming completely on its head. Traditionally, a programmer writes the rules, you feed in some data, and you get an answer. Simple. But with machine learning, you give it the data and the answers you want, and the machine's job is to figure out the rules that connect them. It literally writes its own logic. It's a whole new way of thinking.
So, okay, how do they actually learn? Well, it turns out that kind of like people, machines have different learning styles. Let's break down the three big ones.
First up is something called supervised learning. And honestly, the best way to picture this is a student with a teacher. The teacher gives them a textbook that's just packed with examples, and importantly, all the right answers.
So what you do is you give the machine a huge data set where everything is already labeled. Thousands of pictures labeled cat and thousands labeled dog. The model just churns through all of them, learning the little patterns and features that make a cat and a dog a dog. Once it's learned that, you can show it a totally new picture it's never seen, and it can make a pretty darn good guess on its own.
All right, next up is unsupervised learning. Now, if the last one was a student with a teacher, this one is more like an explorer. Imagine being dropped into a massive library with no card catalog, no signs, nothing. And your job is to just figure it out. Find the patterns on your own. Yeah, with this method, the data has no labels. No right answers are provided. The algorithm's only job is to sift through all this raw information and find its own hidden structures. For instance, a shopping website could use this to automatically group customers into different clusters based on what they buy, maybe discovering a new trend nobody even knew existed.
And that brings us to our third type, reinforcement learning. This one is all about learning from trial and error. Think about learning to ride a bike. You fall, you adjust, you pedal, you get a little further. You get better with every single attempt, good or bad.
So here's how it works. An agent, that's our model, takes an action in some kind of environment, like making a move in a video game. If it's a good move, it gets a reward, like points. If it's a bad move, it gets a penalty. So over millions and millions of tries, its only goal is to get the highest score possible. And by doing that, it eventually learns the absolute best strategies to win, mastering everything from chess to controlling a robot arm.
Okay, so I know these learning methods can sound a little bit like magic, but building a real-world machine learning model, that is a super structured, disciplined process. It's not just some unpredictable black box. There's a playbook.
And pretty much every single project follows these key stages. First, you got to collect the data. Then comes the really hard part, usually pre-processing. That means cleaning up the data, getting it all organized. After that, you pick the right algorithm for your problem, and you train the model. Then you have to test it like crazy to see how well it actually performs. And only when it passes all those tests can you finally deploy it and let it run in the real world.
And that brings us to a really important point. This technology is incredibly powerful, for sure. But with that power comes a huge amount of responsibility, especially when you're talking about the data itself.
There is this classic saying in computer science, and it is the absolute golden rule of machine learning. Garbage in, garbage out.
It's really that simple. A model is just a reflection of the data you feed it. If you train it on messy, incomplete, or biased data, guess what? You're going to get a messy, incomplete, and biased model. The quality of your data is, without a doubt, the most important thing.
And even with good data, during the training process, you have to strike this really delicate balance. See, if your model is too simple, it just won't be smart enough to capture the real patterns in the data. We call that underfitting. But if it gets too complex and learns the training data too well, it starts to memorize all the random noise and tiny details. That's called overfitting. It's like a student who just memorizes the answers for the test but can't solve a single new problem. The goal is to find that perfect sweet spot right in between.
And this all leads to some really serious ethical questions. I mean, if the historical data you're using to train a model has hidden human biases in it, well, the model can learn those biases and even make them worse. This is a huge deal. So engineers have to work really hard to make sure these systems are fair for everybody. And of course, there's always the challenge of protecting all the sensitive personal data that's often needed to make these models work at all. And through all this, it's so important to remember, this isn't magic. Underneath all the cool applications, it's all built on a rock-solid foundation of math and statistics. It's complex things like probability that let a machine weigh evidence, figure out how certain it is about something, and update its beliefs as new information comes in. So, let's end with this thought. As we start to let these learning machines make more and more of the big decisions in our world, things like who gets a loan, or even helping with medical diagnoses, the most important question we have to ask isn't just about the code. It's about us. How do we make sure that the rules these machines learn all on their own are fair, transparent, and actually work for everyone?